going to talk about mid-segment theorem and perpendicular bisectors today. So let's start with the mid-segment theorem, which states the segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So if we draw a triangle and we find the midpoints, remember, in order to find the midpoints, all we have to do is, if we know that this is a length of 14, we're just going to find where it is 7, because that's half of 14. So we'll just estimate that right now. There's a midpoint. I'm going to look at this one. If you were actually doing this, you'd either measure it or you'd use coordinates on a graph. So my midpoint's going to be about here and here. So when I connect these two midpoints, this is my mid-segment. So this is a midpoint, which is halfway across the line, or the segment. And this is my mid-segment. When I connect all of my midpoints, my mid-segments will form a triangle. It's going to be important to find midpoints in your triangles for some of the other lines that we're going to find. And remember that this mid-segment is going to be 1/2 of the length of this line. So if this one is 20, then this line will be 10. And we said that this one was 14, so this one will be 7. If this one is 16, this one will be 8. And of course, these are congruent because we're in the middle of the line. Remember, if we're using the coordinate graph and we have points like 2, 4, and 8, in order to find our midpoint, we're going to add the 2 points together and divide it in half. So our x coordinates, x sub 1, y sub 1, x sub 2, y sub 2. So I add it together and divide by 2, so that gives me 10 halves, which is equal to 5. And then 4 plus 8 divided by 2 equals 12 over 2 equals 6. So my midpoint on the graph would occur at the point 5, 6, where 5 is my x of the midpoint and 6 is my y of the midpoint. The next thing we want to talk about is points of concurrency. And concurrency means, well, to concur. If you've ever watched a medical show or something like that, and the doctors are talking to each other and they're talking about the diagnosis, and the other doctor says, "Oh, I concur," that means that they agree on it. In geometry, concur means where it comes together, like the doctors are agreeing. So this is where our lines come together, and it's called a point of concurrency. So let's see if we can find the points of concurrency for the perpendicular bisectors. Perpendicular again means that we have lines like this. They cross and they're at 90-degree angles. So if I have my triangle, and a bisector means that it cuts it in half. So again, I'm going to find the midpoint. So halfway across my line, it's my midpoint, and then I want it to be perpendicular. Remember, the symbol for perpendicular looks like this, perpendicular. And so I just want to draw a line perpendicular to the midpoint. And wherever it falls on the other segment, that's just where it falls. It's not going to cut that in half. The next one, if I go to halfway here, looks good. And then again, I'm going to draw perpendicular. And this is a lot easier to do if you use a ruler or protractor or something to help you to get your line straight. And my third halfway is going to be about here, and then a perpendicular line from there. So these are all 90-degree angles, which is what perpendicular means. So each of these lines is called a perpendicular bisector. And this point here where they all come together, and you know if you didn't draw them right because they won't come together at a point. So they'll always come together at their point of concurrency if you drew them correctly. We have the perpendicular bisector theorem, which says that if in a plane, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if I have a point on the perpendicular bisector, then if I draw a line here to the endpoints of the segment, straight lines, then these are going to be congruent lines. The next theorem, which is the converse of the perpendicular bisector theorem, and remember, converse just means the opposite. So in a plane, if a point is equidistant from the endpoints of a segment, then it is on a perpendicular bisector. So if I have a point anywhere on this line and I go to the endpoints of the segment and these are congruent lines, then it's on a perpendicular bisector. By definition, I would know that's a perpendicular bisector. Theorem 5.4, concurrency of perpendicular bisectors of a triangle, states that the perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. Not only are these two lines congruent, but if I draw a line from this point to this vertex, this line will also be congruent with the other two. So all three of these lines are congruent. And this point, as I started to say, the point of concurrency is called the circumcenter. Okay, that's all fine and well, but what good does that do? I mean, really, what do we want to do with that? Can you figure out some distances here? If I wanted to place an amusement park along here somewhere, and these were my three cities, would this help me be able to figure out where's a good place to put it so that people can get there and have fun? I have a triangle, and I'm going to call it A, B, C for each of my vertices. And this side is 2x. And this side is 5x minus 6. And I have a perpendicular bisector that comes up, and actually, I didn't draw it very good, but it actually hits that vertex. So if I know that this is perpendicular bisector, I know that it's hitting the vertex. So my theorem told me that if I take a point on my perpendicular bisector, and this is a point on my perpendicular bisector, and I go to the end segments from there, that these two lines are going to be congruent. Knowing that, can I solve for x? How would I do it? Dun, 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 dun. That's right. We're going to set them equal to each other. 2x is equal to 5x minus 6. And now I can solve for x and solve for the sides of the triangle. So I can put my x on the same side. And remember, I like to keep x positive because x is just easier to work with that way. So I'm going to subtract 2x from both sides. And I'm going to add 6 to both sides. When I do that, 2x minus 2x is 0. I have 0 plus 6 is going to give me 6. Over here I have 5x minus 2x is going to give me 3x. Now I still need to get my x by itself. Remember, anytime that we want to solve for x, we need to use the reverse order of operations as we work towards getting x all by itself. So now I'm going to divide by 3, because 3 divided by 3 is equal to 1, so that will leave me with x by itself, and then x is equal to 2. Now be careful, because you might have a question say, what is x equal to? But you might have a question that says, what is the length of the side? And if it asks what is the length of the side, then this is not your answer. You have to take your 2 and you can put it back in either one of these equations. I would pick this one because it's going to be easier. So 2 times 2 is 4, and that would give us the length of the side, which is also the length of this side. Have fun! Thanks for watching Super Math Mommy with mid-segments and points of concurrency for perpendicular bisectors. If you found this video helpful and want to see more, click here to subscribe. If you can't wait and want to see the next point of concurrency, angle bisectors, it's right there. Go ahead, click on it. What are you waiting for? Click on it.